this lesson, we're going to focus on series of transformations. So we're going to be talking about translations, rotations, reflections, and dilations, all happening within the same transformation, okay? So the change in the object, we're going to use multiple of these. So let's take a look at an example of what something like this looks like. So let's look at the figure below. This figure is dilated with a center dilation at the origin and a scale factor of 1/4, and then translated up 5 units. What are the coordinates of the image of point E after these transformations? So we're going to specifically focus on point E. So let's look back at it and we're going to break this problem apart. What it's asking. The figure below is dilated, okay, so that means it's going to shrink or stretch with the center dilation at the origin, and that is good information because that means we're starting at the origin, which means we can focus on the coordinates, okay? So as soon as I see that I can focus on the coordinates, I'm going to come down here and I'm going to find the coordinates of point E. Point E is at +4, -8. Okay, so that's important to know. Anytime we're dilating around the origin, we can focus on the coordinates. All right, and a scale factor of 1/4. So now that we see a scale factor of 1/4, that means that I know that I need to multiply by 1/4. So I'm going to take those coordinates and multiply them by 1/4. So I take and multiply by 1/4. Multiply both coordinates by 1/4. 1/4 of 4 is 1. 1/4 of -8 is -2. Gives me my first transformation goes to 1, -2. So over to 1, down to -2. This is the first image of point E. So then next up, we're going to look at our directions there. And it says that then it is translated up 5 units. So we have to remember that a translation means to slide. So that means that I am going to slide this new image up 5 units. Up 1, 2, 3, 4, 5. That is my location of my second transformation. All right, I know the coordinates of this point are at 1, 3. Over 1, up 3. Found my coordinates. So what are the coordinates of the image of point E after these transformations? It's at 1, 3. All right, feel free to pause, take good notes so that you remember. I highly suggest that you have a highlighter. Just so you know, these Delta Math problems that are in today's homework, there is a paper version in the Unit 6 folder in Schoology so that you can print these off if you'd like to be able to highlight and write over the top of them instead of handwriting all the notes. All right, let's look at another example. Okay, let's look at another example. The figure below is reflected over the x-axis, then rotated 180 degrees clockwise. What are the coordinates of the image of the point R after these transformations? So once again, we are just focusing on point R. Okay, so let's look at the coordinates because if I know I'm focusing on one coordinates, sometimes it's good to have those. So I'm just going to identify that first at -4, -9, just in case I need it later. Okay, have my coordinates. Then I'm going to go back and reread my problem. The figure below is reflected over the x-axis. Reflected. Reflected means to flip. Okay, so I'm going to flip it over the x-axis. So I find the x-axis. Okay, I'm going to flip it over that. So I find how far it is from point R all the way up to the x-axis. So if it was 9 units down, so it was 9 units from R to the x-axis. So then I need to go 9 units up to find the reflection. Okay, so I went 9 units down to get to R. So then I'd go 9 units up to get to R's first image. So that's our first transformation we reflected over the x-axis. Then we're going to rotate 180 degrees clockwise. All right, first thing I'm going to think when I read that rotate 180 degrees clockwise. Let me see if I can get that highlighter. 180 degrees clockwise, I'm rotating it. Immediately I think to myself, okay, what were my rotation rules? That's right, I have x comma y, if rotated 180 degrees, rotates to negative x, negative y. Okay, so if those aren't right there in your notes, go ahead and put that in there, that 180 degree clockwise rotation, you are going to transfer to opposite of x, opposite of y. Okay, so let's figure out what R's coordinates were. -4, +9. Okay, so if we started off with -4, +9 as our xy, we need to transform that by 180 degrees clockwise. So the opposite of x is currently -4, so its opposite would be +4. And then the opposite of y is currently 9, so its opposite would be -9. Okay, so then my second transformation, this rotated 180 degrees, is going to be at 4, -9. Over 4, down 9, plot the point. This is my second transformation. Okay, so that's where the second point ends up. I can check to see if this is a 180 degrees rotation by dropping in a line that comes from the original point, which the original point in our case is where we just started, okay, and then to the origin. Then I can go from the origin to my next point. Sure enough, that makes a straight line, so it's 180 degrees. Okay, so what coordinates of the image point are after these transformations? Well, that image is at 4, -9. All right, so we went through an example of reflection, rotation, translation, and dilation. You're going to see all 4 of these transformations in today's lesson. So make sure you can come back to this video, pause. Also, make sure you're using your notes from the previous lessons.